Over 2 years in my house, I tried several ventilation options with different setups and, as I see it, came to the best solution. To give you the full picture, I'll put together all the successful solutions, and today I'll tell you how I got the maximum ventilation for the minimum amount of money. No matter what, all of us need to buy a kitchen exhaust hood. I tried to find just the exhaust hood casing, but to be honest, they all look pretty unattractive and cost about the same as a fully assembled exhaust hood. At the same time, the noise of the fan right above my head while cooking really annoys me, and in an apartment there's nothing you can do about it, but in your own house it's easy to fix. So I took apart the kitchen exhaust hood and removed the fan along with the control unit and buttons. Now I need something else to put all of this into. You can buy a ready-made ventilation manifold or a special soundproof box and place the fan there. But I was interested in taking the DIY route and making a kind of intake box with my own hands. For this, I took leftover drywall profiles, mineral wool, and of course the drywall itself. I used these materials primarily from a fire safety perspective, since you can notice that all factory-made collectors are usually made of steel. Second, I used leftover materials from construction, which may vary for everyone. I plan to place the resulting box in the under roof cavities at my place, basically in the attic. Since I planned ahead, at the stage of insulation and flooring I laid air ducts between the beams. I used regular round plastic air ducts with a diameter of 100 millimeters. I laid them from the bathroom, toilet and kitchen as separate branches. A special grill was installed in the stretch ceiling. Then I cut the air duct so that it would pass vertically through the mineral wool. It connects well with this grill. I sealed the place where the ventilation duct comes out as carefully as possible with vapor barrier using aluminum tape, and with an elbow fitting I directed it where it was needed. With a bigger budget I would have used these special flexible air ducts. They are more convenient to install and they are antibacterial and anti-static. With regular plastic ones, I've seen static make hair stand up when working with them. That means over time a lot of dust will stick to them. For the exhaust line, plus with a short length like mine, it's not a big problem. That's why I did it this way. My goal wasn't to build perfect ventilation, but to get the best balance of price, effort, and quality. You can always do better, but it will always cost more. And good air ducts would have made the ventilation immediately 20,000 more expensive, because unfortunately they are sold in 50-meter coils. And there's still no way to buy them in smaller lengths. According to sanitary regulations, it's forbidden to combine the kitchen and bathroom exhaust. That's why it was necessary to make 2 holes in the exterior walls of the house for the exhaust. And the house also needs fresh air supply, so there are 2 holes for that as well. For this I used a hammer drill and a 120mm concrete core bit. I glued insulation into the resulting hole using sealant, installed grills on the outside, and based on experience, I also added a mesh to it. I used the leftover mesh from plastering work. There are ready-made grills with fine mesh, and it's better to buy those right away. I put a filter in the hole so insects and pollen definitely won't get into the house, and there will be fewer unpleasant odors, especially if one of the neighbors decides to burn something. The insulation, grills, and filters all came included with the air inlet valves. I'll talk about them in more detail a bit later, and in addition to them, you need an air quality monitor and another exhaust duct fan for the bathroom. For the second exhaust fan I chose this one. It's quite expensive, but it's definitely good, quiet, and most importantly durable. According to my calculations, I needed a capacity of 200 cubic meters per hour. The fan delivers this on the third speed, that is, on the maximum setting. If your budget allows, it's better to buy a fan that provides the required capacity at the first speed, so it will work even quieter and last even longer. To install the duct fan, I had to disassemble the previous one. I'll get back to all its drawbacks a bit later. One of the nuances I faced was that I really wanted the exhaust air outlet from the house to be, first of all, straight, without any turns, so the air wouldn't hit anything, and secondly, as short as possible. This way there will be less noise and less performance loss. Using scraps of furniture board, a confirmat drill bit, and furniture fasteners, I assembled a console on which I mounted the duct fan housing. I placed the resulting structure on the wall right up against the outlet. I pressed the insulation to the inline fan with a clamp and got the shortest, straightest air outlet to the outside. Before connecting the duct fan and the air ducts, I still needed to buy a steel box where it's convenient to change the filter. It's necessary so that over time the inline fan doesn't get clogged with dust and lose its efficiency. I also bought something called a silencer. Its job is to reduce the noise level that gets transmitted through the air ducts to the first floor. Since I only need to connect 3 air ducts, I didn't do it properly through a manifold, but just used a T. An important detail is that all connections must be airtight. For this, I sealed everything with aluminum tape. After the T, I attached a box with a filter followed by the silencer, then into the inline fan. I wanted to remove the flexible duct entirely, but while sitting on the couch, it all seemed easy enough. But when I started figuring out what kind of twists and turns I needed here, I realized that no matter how you look at it, you can't do without the flexible duct, and how much flexible air ducts actually help and how convenient they are to use. If I had known at the beginning of construction that there were good flexible air ducts, I would have bought a whole coil to lay them properly in the ceiling. For the kitchen, I would have run them behind it and avoided using that corrugated pipe. I also needed ventilation for the septic tank, and they would have worked well for that too. Actually, maybe even somewhere into the storm drain too. This coil would have been a hit on the construction site if I'd known it existed from the start. The noise from the kitchen hood fan and the bathroom fan traveled through the air duct, so you could hear the fan running through it. You can't hear anything through the ceiling, and the sound travels through this channel because that's our weakest link. But with a silencer that doesn't happen at all. But those duct fans, the other type, they're quiet by themselves. They even have a silent version, which is even quieter. And with them you can pay extra for the silent version of that duct fan and not buy a silencer.
So here's the
ventilation
grate in the bathroom. We hold a piece of paper up here and look, it gets sucked right in. It's like it wants a new iPhone.
In a proper muffler setup, there are actually 2, one before the inline fan and one after, so that when you're outside you can't hear anything through the exhaust outlet. No noise outside at all. Right now there's wind here, so you won't hear it on camera, but I can hear with my ear that air is blowing from that hole, and to make it as comfortable as possible outside, you might want to put one right outside after the inline duct fan. But for me it turns out that I rarely ever do anything on this side of the house. And well, it doesn't bother me that there's some noise there, plus, in general, it's always windy, and if you're on the porch or on the terrace on the other side of the house, you can't hear anything blowing from there. And even here, say 5 meters away, you can't hear anything blowing. However, for someone with a different setup, it could be annoying. Skylight windows should be installed in the attic soon, and I'll try to solve the ventilation issue in the 2 future rooms using these windows, because they should have fresh air vents already built into the design. The windows have a capacity of up to 40 cubic meters per hour, so thanks to the windows on the opposite side of the house, there should be an air supply without needing to open them. I'll see how it goes, and if it doesn't work, then I'll add another outlet to the main inline fan, maybe from the utility niche or from the room. I also bought a couple more outdoor grills with fine mesh inside. I had the idea to replace the dark grill with a white one on the most visible part of the house so it wouldn't stand out. Somehow it feels like it didn't get any better. Actually, in principle, it was supposed to be right here. There shouldn't have been a hole here, it should have been over here in the second row and it would have been hidden behind the cladding and that would have been perfect. So of course it's better not to make extra holes on the facade. And my homemade box with the kitchen fan needed some improvements. I had to move the buttons from it back to the kitchen. To do this, I tried to run a wire from the hood casing through the furniture, the kitchen, and the ceiling, and just like that, with one simple move, a 5-minute job turns into an all-day project. I was too lazy to go to the store for a factory-made ring, so I made a plastic ring from a vitamin jar lid and glued it to the stretch ceiling fabric with super glue. I cut a hole and used the ring to prevent ceiling tears, then pushed the wire through to the attic. The flimsy wire didn't want to go through, so a rigid electrical cable taped on with electrical tape to use as a pull-through helped out. I connected the exhaust control unit to the extended wire through a terminal block. I installed all this back into the factory exhaust hood housing and, in addition to the mesh grille, added a filter to protect against grease. I finished assembling this box, sealed it, and during the assembly process I realized that a backdraft damper was missing here. Because when it's on, everything blows in that direction, but when it's off, it starts working as an air supply. Because that exhaust fan pulls and it ends up sucking air from down there through the exhaust. But I don't really care about that corrugated pipe. I fixed it down there, but I definitely need to remove it from here. I'll just buy that grill with a backdraft damper. And apparently a plastic duct goes here for now, because while it's working, it moves and makes these kinds of noises, which is annoying. This corrugated pipe is quiet, it even moves when nothing is happening. I considered replacing it with a plastic one, but decided not to since everything works. When I get the chance to use good flexible ones, then I'll replace it. On the first floor, everything is fine in terms of noise level. This thing turns on occasionally, and that thing allows it. Currently, you can only hear it through the open stairwell. Once partitions with doors are installed, you won't hear anything. If I, for example, go to the bedroom and close the door, that's it. I can't hear the main inline fan at all. You can only hear it in the hallway through the opening. You can't hear it at all in the bathroom or the toilet, not even a hint of it. And in the rooms that are planned for the attic, I'll later cover up these technical niches, and everything will be insulated here, so they won't be a bother in the rooms either. So how does this whole system work as of today? Today, for example, my wife is at work somewhere, and I just came back from the hardware store. At home, the air quality monitor shows 400 units. That's ideal air, because I practically live in the forest. And at the same time, the fresh air intake valves in my house are closed, and the main duct fan is running 24/7. And it turns out that it's not running at full capacity, but just enough so that the air in the house stays fresh and money doesn't go out the window in winter. The house doesn't get stuffy, and the air stays fresh, keeping it ventilated even when no one is home. And for example, when I come home I can go wash my hands or use the bathroom and the exhaust still works to some extent. There's no need to turn it on separately, it all works automatically. I started breathing and the CO2 level went up to 600 units. With the fresh air intake valves closed, this happens very quickly. My first fresh air intake valve opens, it works in automatic mode, takes readings from the air quality monitor, and operates on its own. Next, for example, there's the duration factor. Either someone shows up, like my wife comes home, or some other people arrive, or you start breathing more heavily because of some activity. When the air quality monitor readings increase to 800, the second fresh air intake valve opens. Accordingly, the exhaust performance increased even more because to blow air out, it needs to blow air in. If there's no air coming in, it can't work. It needs to get air from somewhere to operate. So it turns out that we increased its performance and then we hit the limit of its performance. And if I had additional rooms on the first floor, there would also be fresh air intake valves in them, and in that case I would need a slightly more powerful inline fan, not for 200 but for about 250 cubic meters. Let's say more people start coming in. And when the house turns into a marketplace, all you need to do is go to the kitchen and turn on the kitchen exhaust. An additional fan will turn on, and the exhaust performance will double, and it will pull out everything that needs to be removed. Also, if you're cooking something, you turn on the exhaust as usual. And all these gatherings with friends are usually connected to something you're doing in the kitchen, and it doesn't make things difficult. And it turns out that the system is, in a way, automated, so it works without me having to worry about constantly opening or closing something or pressing some buttons. Overall, everything works by itself. Basically, I only need to use the traditional kitchen hood, and it doesn't bother me at all because you can't hear it. The downside of a quiet kitchen hood is that it's quiet, as paradoxical as that may sound. The point is, with my previous ventilation setup, when I turned it on here with the wireless switch button, a smart plug would activate and that's it. The fan would turn on remotely. But the thing is, when you're cooking here, you can't tell if you turned the hood on or not, if you forgot to turn it off or not. It was unclear what was going on at all. But thanks to these buttons, it's immediately clear whether it's on or not, and at what speed. So overall, it's much more convenient this way. It turns out it's not a perfect system. I wanted to go for full automation, but that's a whole different price, and I'll talk about that a bit later. Overall, I'm very satisfied with what I've achieved because in the initial version there just wasn't enough ventilation. Yes, when my wife and I were at home, everything was fine, but when guests came over, we wanted more ventilation and the inline duct fan couldn't handle it, so we had to open the windows, plus it was noisy. When my wife cooks and I'm on the computer, the noise is so annoying I can't get anything done. That's a downside of working from home. Now this thing doesn't bother me at all. It quietly hums somewhere out of my hearing range. More people have joined. Now I can increase the airflow even more with the press of a single button. In the second iteration of the exhaust system I made, the exhaust ventilation, I would have had to go to the second floor to press this button. But who would do that? That's just nonsense. Now that the button is in the kitchen, it's convenient. Another downside of my second version of the ventilation is that I installed an exhaust fan that was too powerful as the main one. Unfortunately, the technical documentation doesn't say how many cubic meters it moves at the first speed, but it feels like it's over 300 cubic meters. In the summer, that's great, but for example, in the winter, when I saw the heating bill, in the month when it should have been 7,000 for electricity but ended up being 10,000, I was like, that's a bit too much, I need to do something about it. Plus, when it was below zero outside, minus 27, when I was at home with the exhaust fan on, it got cold. The house couldn't heat up fast enough. I had to keep turning the exhaust fan on and off, switching it off a couple of times. During the day, I usually only turned it on when I went to take a shower because it gets too cold, it blows too much. You need less power, especially when you're home alone. And in the kitchen too, the exhaust hood didn't work well. It was kind of combined with everything, and even with the extra inline duct fan that was supposed to pull air out, the performance was still poor. Also, the air ducts should be the same length. If they're different lengths, the shorter one will pull in more air, and the longer one will pull in less. So I ended up with one vent duct, and in the bathroom and toilet it was short. And from the kitchen it goes through the whole house, and there it barely pulled any air at all. It was really not good. I did it that way on purpose because I didn't want to make holes in the walls, I didn't want to make an extra hole. I really tried to avoid it, but as a result of the experiment I realized that no matter what, you can't do without extra holes. Plus, the noise through the air ducts is gone, and it's also convenient with the filter because there's a factory box. You just unscrew 2 bolts, take it out, replace it, and everything works perfectly. The filter on the exhaust is also changed at the beginning of this duct, and that's it. The same duct will be dust-free and clean. I saw what was happening with the ducts when I was taking this system apart. It turned out that the vent channel from the kitchen was very clean. The one from the toilet was more or less okay. It was of medium length, and the one from the bathroom was the shortest. It had the strongest suction, and in just a year it got packed with dust. That dust needed to be removed from there. Now about the dust in the supply valves. A filter is installed, and even though nothing comes in from outside, we still get dust from hair, skin, and clothes. People produce this dust, and dust is present in the air in general, just like in an apartment more or less. There's no way to get rid of it, and to remove it somehow you need a special air purifier. I don't have a situation where there's a real dust suspension in the air because the ventilation is working powerfully. It's just standard like everyone else lying on the surfaces. If you don't wipe something there, like some cabinets or shelves, dust will accumulate. If you run your finger over it, you'll see it on your finger. The whole ventilation system cost me about 60,000. Someone might say that's a lot of money, someone else might say it's cheap, because it all depends on each person's needs. I consider this a kind of middle ground, because for all the fans of natural ventilation, just install an air quality monitor at your place and look at the actual numbers. Not your feelings, but the actual readings from the device can be really surprising. Installing some kind of heat recovery ventilators in my 80 square meter house is not economically feasible. I did the math and it will never pay off. Those small wall-mounted ones, the kind that are mobile, they're not very effective and in fact they won't pay off either. The most they can do is slightly increase living comfort, because in winter the air supplied to the house will be a bit warmer. Because when it's 20 below at my place, the air comes in through the intake valves. The house gets outside air at around 20 below, and that's very cold air. Actually, people have also asked me if I want to heat the incoming air. No, I don't want to heat it, because what's important here is the proper placement of these supply valves, and also having an adjustable damper. It can be adjusted by 3 parameters: temperature, humidity, and carbon dioxide. If it reaches a certain temperature, like an uncomfortable one, you can set it. It will just close, that's it, and the valve will work. It won't be completely sealed, so air will still get in, but there won't be that strong flow like from a pipe, and it won't cause discomfort. Also, it's important to choose the right place to install the supply valves. The first time I installed it above my bed right over my head and I woke up with a runny nose. I had to move it urgently, so I put it in a place where people aren't constantly present, and things got much better. In the living room, the supply valve is also installed incorrectly. It should have been installed somewhere else, but I didn't reinstall this one. I decided not to reinstall it because it's rare that something happens where it gets in the way. And even when, let's say, a crowd of people gathers there, it's generally fine if it's slightly open, nothing bad will happen. I don't have any desire to install any kind of air ventilators with heating. If I had installed it correctly, everything would have been fine. There were a lot of comments about the person with the codename InventQuadro. I've been subscribed for a year, I know everything perfectly well. Just Google it, take a look, and as people correctly pointed out in the comments, the person became the evil he was fighting against. It all started as some kind of budget ventilation, but it turned into a solution that's not the most affordable. Because a good system like this, with full automation for my house, with all the bells and whistles, will cost about 300,000. Maybe rounding up a bit, but that's the general price range. That's hundreds of thousands of rubles, not tens of thousands, and paying like 10% of the house's cost just for ventilation, in my opinion, is too much. I'm not trying to push my homemade DIY contraption on anyone that I use here myself. I'm just looking for some kind of solution that offers good quality for a reasonable price. Because, for example, if you try to save even more, you can buy, say, a duct fan not for 15,000 but for 5,000. You can also find fresh air intake valves for a lower price. The only issue is I don't know where to find automatic dampers for a lower price, since this option is already quite affordable, especially for automation. If you need valves with a mechanical damper, you can buy ones that you can simply open and close by hand. There are also some of those for about 3,000, which I wouldn't buy a second time because I've been in rental houses, I've seen how it works, I've lived there. Cheap valves are basically just a hole to the outside. What I have is a wall opening. A hole in the sense that I don't even know how they achieve that. Turns out you can't actually hear the street through it. The soundproofing is almost like a closed window, which is really good, but with the cheapest regular ones it's basically just a hole to the street and you hear everything. So what's the point of it? It's not clear. You might as well just open the windows. And my goal was to achieve the perfect level of comfort so that I would never have to open the windows. If someone likes to do that, I'm not stopping you. Some people like that sort of thing, for example in a country house setting. The neighbors showed up, grabbed beer on Friday and partied for 2 straight days. Honestly, I don't want to hear it. Unfortunately, even in your own house, you can't completely get rid of neighbors. You can, but it costs a lot more. Inside my house, though, I managed to do well in that regard. I also have a supply air valve here, which has a fan installed inside so it can force fresh air into the room. And in theory, this idea sounds great. In theory, this idea turned out to be complete nonsense, totally ineffective. Not only that, but in winter with this extra supply the air gets very cold, making it extremely uncomfortable. Let's say it was placed somewhere people aren't present. Even with proper installation, another problem still arises. It turns out to be too noisy, incredibly noisy, and it's annoying, it irritates you. Because the principle we use for building ventilation with these valves is that in clean rooms there's supply and in dirty rooms there's exhaust. That is, somewhere in the bedroom, living room, or other living spaces we install supply valves, and from places like the toilet, bathroom, restroom, kitchen, and maybe some other technical room like a boiler room we have exhaust. And if we have this device with an extra fan for supply in the bedroom, that is, when you try to fall asleep and it turns on even at the second speed, that's it. It will annoy you, irritate you, and you won't be able to sleep. So either just use a mechanical damper that you adjust by hand, or a smart damper that can open by itself. A fan is not needed there. What else I'd like to mention about ventilation is that in fact many people don't realize how important it is. And after moving into the new house, my headaches stopped. I started feeling good again like a human being. I fall asleep easily. I wake up feeling great. I'm full of strength and energy. I constantly want to do something, to go somewhere. I'm always inspired. It's like I've become younger, even though every second I'm getting closer to the grave. And one of the aspects of this is that everything in my bedroom is anatomical, it's very comfortable for me, but the second, no less important, is that I'm constantly breathing fresh air. There's always good air around my house. I took measurements in the apartment when I was renting, and the carbon dioxide level was always around 1500 to 2000, especially if you live with a gas stove, it would even go over 2500. And yes, you open the windows, like you aired it out, everything's fine, it dropped to around 400, but as soon as you close the windows, in an hour it's back to 1500 or 2000, and then people complain like, oh, I don't feel like doing anything, I feel weak, sluggish, kind of meh, and that's because you need to breathe fresh air. I used to go to the pharmacy all the time for ibuprofen because I constantly had headaches, but now I can't even remember the last time I was at the pharmacy. And good ventilation will save you money on pills, time spent going to the pharmacy, it will extend your life and improve your quality of life, so ventilation is really important. As you can see, I bought the cheapest components because again the goal was not to make it cheap but to do it well and to show the basic principle of building ventilation in the video. You can always look for alternative component options on marketplaces like on Mega Market, for example. Plus, don't forget, I'm just a self-builder and I'm showing my own amateur work. Recently, real professionals in the field of ventilation contacted me and prepared a ventilation plan for my house, as competent specialists see it. I shared the drawings on my Telegram channel, the link is in the description. I'm continuing to work on the other elements in the house. New videos are coming soon, so subscribe to the channel so you don't miss them, and see you in the next video.